Hello students, very good morning. Myself Hetal Shah from New LGIT Institute of Engineering and Technology. Today we are going to discuss the Unit 4 partial derivative with the other example of the higher order partial derivative. So let's start the example. Our first question is if u equal to log x cube plus y cube plus z cube minus 3xyz, then show that del by del x plus del by del y plus del by del z whole square into u is equal to minus 9 upon x plus y plus z whole square. Okay, so let's start the solution. As we want to find the del by del x plus del by del y plus del by del z whole square into u, so it means del by del x plus del by del y plus del by del z into the same bracket del by del x plus del by del y plus del by del z into u. Now we first apply this u into this first bracket, that is here del by del x plus del by del y plus del by del z, keep it same, and after applying u in this first bracket, that is del u by del x, this one is del u by del y and this is del u by del z. So if I say this bracket as v, then here del by del x plus del by del y plus del by del z, and this is v. So, and if I am telling this equation as equation 1, so the value of v is what? Here del u by del x plus del u by del y plus del u by del z. So first I would find out the value of v with the differentiation of u with respect to x, with respect to y and with respect to z, and after summation of all these three values I get the value of v. Okay, so first I am going to find out the value of v. For that, here my u is log x cube plus y cube plus z cube minus 3xyz. Okay, so differentiation of u partially with respect to x, y and z, that is del u by del x. Here applying the log rule, that is 1 upon x cube plus y cube plus z cube minus 3xyz, and the chain rule, that is 3x square minus 3yz. Similarly, for del u by del y, that is 1 upon x cube plus y cube plus z cube minus 3xyz. Here 3y square minus 3xz, and the same for del u by del z, that is 1 upon x cube plus y cube plus z cube minus 3xyz. This is here 3z square minus 3xy. Okay, so now I am going to the summation of all these values for v. Okay, as my v is del u by del x plus del u by del y plus del u by del z. So after substituting the value for this equation, that is 3x square minus 3yz. This is for del u by del x, and the denominator are same, that is x cube plus y cube plus z cube minus 3xyz. Here plus 3y square minus 3xz. This is for del u by del y, and for del u by del z, that is 3z square minus 3xy. So if I keep 3 as a common from the numerator, then 3 x square plus y square plus z square minus xy minus yz minus xz, and my denominator is x cube plus y cube plus z cube minus 3xyz. So if I multiply and divide with x plus y plus z, then the multiplication of these two brackets is this equation, that is 3x cube plus y cube plus z cube minus 3xyz. See, multiplication of these two brackets, it gives this one, and the denominator is x cube plus y cube plus z cube minus 3xyz, and here the remaining term is 1 upon x plus y plus z. So both bracket will be cancelled out, and the value of v is 3 upon x plus y plus z. So now I am going to substitute of value of v in our given equation 1. Okay, so our equation 1 is, substitute value of v in equation 1, that is del by del x plus del by del y plus del by del z whole square into u is equal to del by del x plus del by del y plus del by del z into v, and v is 3 upon x plus y plus z. Okay, so now I am first apply del by del x for this bracket, then del by del y for this, and del by del z. So the derivative of 3 upon x plus y plus z with respect to x, that is minus 3 upon x plus y plus z whole square. Similarly, for y, that is minus 3 upon x plus y plus z whole square, and for z, that is again minus 3 upon x plus y plus z whole square. So my answer is minus 9 upon x plus y plus z whole square. Okay, this is the solution which I want to prove. Del by del y, here del by del z whole square into u. So this is the solution. Okay, see the question. This is what we want to prove. So students, this is the IMP example. Please go through it. Now we'll move for another IMP example, that is if u is equal to f of r and r square is x square plus y square plus z square, prove that del square u upon del x square plus del square u upon del y square plus del square u upon del z square is equal to f double dash r plus 2 times f dash r upon r. Okay, so let's start the solution. Students, here our given function u is depends on r, and r is depends on x, y, z. So this is u depends on r, and r is depends on x, y, and z. So first, if I want to the derivative of u with respect to x, then first I have to go for the del u by del r, then I find del r by del x. So first I am starting with r square is equal to x square plus y square plus z square. So the derivative of this r with respect to x, y, and z, that is 2r del r by del x is equal to 2x, implies del r by del x is equal to x by r. Similarly, del r by del y, that is y by r, and again the similarly del r by del z, that is z by r. Okay, so these are the value of del r by del x, del r by del y, and del r by del z. Now I am starting the derivative of u with respect to x. So my given function u is f of r, right? And as you all know, r square is x square plus y square plus z square. So differentiating u partially with respect to x, that is del u by del x is equal to f dash r into del r by del x. Here f dash r and the value of del r by del x, that is x upon r. Okay, now differentiating del u by del x partially with respect to x again. So del square u upon del x square, that is f double dash r at the time x upon r, keep it same, plus f dash r into 1 upon r, here the derivative of x is 1, plus f dash r into x and 1 upon r, that is minus 1 upon r square, into del r by del x, that is into del r by del x. Students, here f double dash r into del r by del x, right? So f double dash r del r by del x, that is x upon r, here x upon r, so x square upon r square, plus f dash r upon into 1 upon r, here minus f dash r into here the value of del r by del x, that is x upon r, so here x square upon r cube. So this is my equation 1. Similarly, for del square u by del y square, that is here f double dash r upon into y square upon r square. So f double dash r into y square upon r square. The second term will be same, that is f dash r upon r, and the last term, that is here f dash r y square upon r cube. F dash r y square upon r cube. This is my equation 2. And similarly for del square u upon del z square, that is f double dash r z square upon r square plus f dash r upon r minus f dash r upon z square into r cube. This is my equation 3. So adding equation 1, 2 and 3, I have del square u upon del x square plus del square u upon del y square and del square u upon del z square, that is the summation of first 3 term, that is f double dash r upon r square, here x square plus y square plus z square, plus the summation of the middle 3 term, that is 3 f dash r upon r, and the summation of last 3 terms, that is f dash r upon r cube, here x square plus y square plus z square. So this is x square plus y square plus z square is nothing but this one is r square. So both will be cancelled out and my final answer is f double dash r plus 3 f dash r upon r, and here this one is again r square. So 1 r square will be cancelled out, 1 r will be remain in the denominator, that is minus f dash r upon r, and the final simplification is f double dash r plus 2 times f dash r upon r. Students, the solution which we want to prove, see the question. Okay, so feel free to contact me for any query. Till that, enjoy the study. Thank you.